All right, so for our warm-up, we had to talk about this square root function a little bit. And this square root function, okay, so yesterday, right, we talked about a type of transformation for parent functions, which was translations, which is where you shift up, you shift down, you shift left, you shift right. And while we did that, we worked with the quadratic function and the absolute value function so that we could both practice using those functions and learn about a type of transformation, a way that functions can change. Now we're going to do it again today, where we're going to practice with the square root function, a third parent function, and we're going to talk about a different type of transformation called reflection. So we're going to do a couple different things at once, right? But first, we're going to get into this function and make sure we can do what we did yesterday with this function too. All right? So for your warm-up, well, you went back to your notes and you looked at your old XY table that you made for this, and it'll be the last time you have to do that because I'm going to teach you, or at least point out the pattern. Maybe you noticed it already. But before we know the pattern, we need to find some X's and some Y's, right? So you might say, okay, I need to know some points here. -1, 1, oh no, not 1, 0, 1, 2, 3, 4, and 9. That's weird. Why did I skip to 4 and 9?
Because it's radical.
Because what?
It's radical.
It's a strategy? What do you mean?
It's a radical.
Oh, it's a radical. Yeah, because I'm just kind of thinking ahead, and I know I have to square root all those numbers, so I might as well pick some ones that are nice and square rootable, okay? So remember, a table is what you want to make it. So you're just trying to get good points. So yeah, I'm going to do my best with these, but I want some good points too. All right, so -1. So for every one of these, I'm going to square root it. So the square root of -1, the square root of 0, the square root of 1, square root of 2, square root of 3, square root of 4, square root of 9. You have to write that a million times, right? You know what you're doing. But that's what you're doing, right? Square root of -1, what's that?
1.
What is it? 1? I can't hear. Square root of -1 is 1, so 1 times 1 is -1. No.
No.
Square root 1 times 1 is a positive 1. So the square root of -1,
-1 times -1 is a 1.
and -1 times -1 isn't 1. So what the heck is the square root of -1 then?
1.
It's undefined. There is no answer to this question. You can't square root a negative, remember? You can't multiply anything by itself and get a negative. So this does not exist.
So
It's undefined.
So it's not a real number.
So it's not a real number, and it doesn't belong on our graph. It's undefined. There's no output for that input, so there's no y to that x, so there's no point. Okay? So you can't do that one, but that's okay. That just means we won't have a point there. Square root of 0 is?
0.
Square root of 1 is? 1. Square root of 2, we would use our calculator and we would get
1.4.
1.4. Square root of 3, we would use our calculator and we get
1.7.
1.7. Square root of 4 is 2, square root of 9 is 3. Now we have some x, y values we can add to our graph, right? 0, 0, 1, 1, 2, 1.4 about, 3, 1.7 about, 4, 2, and then 9, 3. So you can see it kind of curves that way, and it goes like this, and that's our function, okay? Now, I promised you that you won't have to use an XY table. Remember yesterday with the parabola, we said no need for an XY anymore. It goes over 1 up 1, over 4 up 2, over 9 up 3. So we're going to look for a similar pattern here, okay? Now, we want good points for our pattern. Is this kind of a good point that we're going to want to find every time? No. No, probably not. Especially if we're not even starting at 0. That'd be really weird. So what are our good points? What do we think?
0, 1.
Here, right? Here, here, and here, right? Those are our good points that we would probably want to find every time, okay? No matter where we start with this thing. So let's talk about the key points pattern. The key points pattern. All right, so you want to have a starting point, right? You start at 0, 0, just like with the other ones, right? And then you go where? Over and up what?
1.
Over 1 up 1. And you go over 4 up 2. And then if you can, you go over 9 up 3, but you're not always going to be able to, depending on the size of your graph. That's pretty far out, but you'll see it's going to come up sometimes. Okay, so that is, what was it before? That's your pattern here, right? Which is helpful because if somebody did like -2 here and moved your starting point down, well, you would start here. And you wouldn't have to calculate the rest of your points. You know, oh, I go over 1 up 1, over 4 up 2, over 9 up 3. And there's my graph, right? So it's the same concept. You're just moving those key points to your new starting point, okay? It's just a different function, okay? So what I want you to do now, oh, real quick, domain and range. Forget our friends, the domain range. Remember, domain is all our possible x values. So I start over here and I'm like, no, 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 yes. Where's my first point? 0. And then where does it stop? Never. So x can be anywhere from 0 to infinity. So how do we write that? We say, oh, x is greater than or equal to 0. That tells the story. X can be 0 or more than 0. That's the story. Y, I go down here, no, 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 yes. Where does the y start? 0 again. And then where does it end?
Infinite.
Infinite, right? It kind of looks like it ends at 3, but this doesn't just go straight across. It keeps going up, keeps going up, forever, right? So y is also greater than or equal to 0. It flattens out, but hey, as long as you're going up a little bit, you're going to get to infinity, okay? All right, so what I want you to do now is you're going to skip, we're going to come back to this function notation section. I want you to practice or try to do these functions using what you learned yesterday about moving up, down, left, right, and what you learned in the warm-up about your key points and your pattern for square roots, okay? So give these 3 problems a try. I'll give you a minute to do that, and then we'll talk about them, and then we're gonna go back up to that function notation thing so I can talk about something real quick. And remember, you're thinking inside and outside, right? So for this, inside means under the radical, outside means not under the radical, okay? Okay, so remember, outside means up and down. Inside, meaning which is under the radical in this case, means left and right, and it's going to behave the same way as yesterday. So if I look here, this is outside, so I'm going to go down, right? Down 5. And what's going to go down? Well, the whole thing, right? So you can just move every point, right? Every key point down 5, and you'll have your graph. Or you can say, well, I know the starting point is going to go down. So this will go down to 5, -5. And then I know my pattern now, which is over 1 up 1, over 4 up 2, right? And we're not going to get to 9 here. Now, one thing I will say here is don't do this. What's the difference? What did I do differently that was wrong?
The line is here, you just went straight after
Okay,
Point.
let me make it a curve. So wrong. What did I do?
Because like there's a point, like the line is like on a point.
Kinda. Anybody want to add to that? Yeah.
You kind of just went from point to point, not making it a curve.
Okay. All those things are true. What? How far did I go up right there? Above 3. And we don't get to 3 until we move over how many spots? 9. And that's not 9 spots, right? So if you don't get to 9, stay under that 3 line. Does that make sense? So this should not end up above that line. Does that make sense? No, that's a little nitpicky, but we want to be accurate, right? And that wouldn't be accurate. Okay, this one goes which way?
Up 3. No,
It's
in it.
under the radical. So it's left or right. So which one is it?
Left.
Left 3, right? You caught it, right? As soon as you saw it, you were like, oh.
Yeah.
So my starting point goes left 3, over 1 up 1, over 4 up 2, and then this one I could do over 9 up 3. How did I do that so quick without counting? I didn't count 9 spots. What did I do? Correct. Trying to give you some tricks here.
3.
Yeah. 3, 6, 9, right? You don't have to actually count every spot, but if you want to, you can. All right. There we go. That one's intact. This one. And notice I'm still using that strategy where I kind of color code it and dissect all the different things. This is going to go right 1 and up 2. Do we agree? Yep. Okay, so let's use this color. Right 1 up 2. It's right there. And I'm going to go over 1 up 1, over 4 up 2, and I end up with that. Okay? Questions?
Do we go to the very ridge?
Did it say? I don't think I was asking. I just wanted to clarify that. But hey, let's do it for one of these because that is an actually important thing here, and you're going to be asked that maybe on a homework, right? Because your domain, no, I appreciate you bringing this up. Because your domain range change. Let's do this one, right? My domain. Well, if I'm looking at the pink function, right? No. What? There's my first x value. Where is it? 1, and then it does a stop after that. No, so it's not x is greater than or equal to 0 anymore. It's x is greater than or equal to 1. And then my range, so glad you brought this up. Well, I'm bottom, no, yes. Where's my first y value? 2, and then it goes forever. So y is greater than or equal to 2. There you go. You're ahead of the other classes now. They didn't do that. Are you happy? All right, moving to the back up here. So function notation. So I just want to explain something that was a little confusing yesterday, partly because I got a question that I was like, gotta think about that. I tried to explain it. I'm gonna try it again, okay? The question is, why does f of x equals the square root of x minus, let's say 4, go right? You don't have to write this question down unless you want to, and not left like we think it should. If you're subtracting, why shouldn't it go left? Right? Anybody else wondering this?
Yes.
Yes.
I got some yeses, so I'm sorry. I gotta explain it. All right, so think about this, right? Okay, if I have f of x equals the square root of x, just the parent function, right? And then I said, okay, f of 4, what is that asking me to do? It's saying plug in 4. And what do I get out? 2. So I end up with the point 4, 2. All right? Now what if I said, okay, actually now the function is f of x equals the square root of x minus 4. And I'm going to ask you to find f of 4. Well, you plug in that 4. What is 4 minus 4? 0. What is the square root of 0? 0. Okay. So you end up with the point 4, 0. So what happened to the y value when you did that? It went from 4, 2. Here, let's look at it on the graph. All right. It went in the parent function. We had 4, 2 here. And then in the other function, we got 4, 0, right? Okay. Well, let's add another point. What if I did 5? 5 minus 1, that's square root of 1, right? And that is what? What is 5? If I put in 5 to this function, 5 minus 1 is 1. I mean, sorry. Sorry, 5 minus 4 is 1. The square root of 1 is 1. So I'd have the point 5, 1. Right?
It's a linear.
Well, it's up 1 over 1, right? Now let's say I plugged in, I don't know, 8. And I'm all the way out here now, right? At 8. 8 minus 4 is what? Square root of 4 is 2. So at 8, I'm at 2. And see how I'm all the way over here with all my outputs. Whereas my parent function would have had 0, 0, 1, 1, and 4, 2 over here. Right? So, what happened here? Well, we took our input and we said, well, actually, instead of giving me the input for 4, can you give me the input, instead of giving me the output for 4, can you give me the output for 4 left of that? So at 4, I didn't get the output that I would usually get at 4. I got the output that you usually get at 0. Because I subtracted 4 from my input before I plugged it into the function. Okay? I know, it's kind of like, hard to get your head around, right? But for those of you who are trying to understand this at a higher level, think of it this way. When you mess with the outside, you're messing with the y, right? You're adding, subtracting, and you move up and down. When you mess with the inside, you're messing with your x. You're messing with your input, and you move the input accordingly before it gets plugged into the function, before you get your output, right? So if you subtract 4 from your input before you even put it into the function, you're going to get the point you usually would have got 4 to the left, which in this case was that point. In this case was that point. In this case was that point. Okay? Hopefully that was a little bit more, and I'll keep trying to, as we go through these, keep trying to hammer that input-output concept. I know that can be a little confusing. Here's the deal. You don't actually have to know all that if you just remember, minus on the inside goes right, positive on the inside goes left. But hey, when you ask why, I'm going to try to answer the why. Okay? All right. Are we ready to move on? Any questions on what I...
Function notation.
So function notation, this is function notation, right? Using this, using this, using this. So that was just me using function notation, inputs and outputs to try to explain it, okay? So if you want to write down this part, the bottom part, I'll give you a chance to write that down. Oh, wow, we only have 9 minutes. All right, so on the back, if you're ready, this is where we're going to start using Desmos, so you can get started while we're writing this down. So on the back, either on your computer or if you want to pull up Desmos on your phone, you're going to plug in those functions and answer the question of what happens to the function when you change it in those ways, in this new way. Are we ready for me to scroll to it?
Yeah.
Okay. So, for instance, we know that this is the function right here, y equals square root of x, right? So use Desmos and then find out, well, what happens when you put a little negative in the front? And use Desmos to find out what happens when you put a little negative in the inside, in the front. Okay?
And then isn't in the inside like it doesn't work? Like,
Depends on your number. What if your number was -4? Then it becomes -4 and then it works,
oh
right? So it all depends. But you're getting close to what's going to
yeah. If
happen.
it's positive, we just say undefined or.
Yeah, so now your positives become undefined. Very good, yeah. So 4 would be undefined now. But would -4? No, right? That's actually a little clue into what happens. So go ahead. Everyone should be exploring.
Wait, if it isn't inside,
Mhm.
it's not right. Yo, wait a minute.
Yo.
Oh, I did it wrong.
All right, so again, we're seeing what happens, and then we're gonna write down our results, and then we're gonna make a prediction, and then we're gonna extract a rule out of this that we can use going forward. Part of the reason I'm getting you to use Desmos right now is so that you get used to using it, so that when you're doing your homework, and I give you something crazy eventually in this chapter, like y equals -3, x plus 2 squared minus 10, and you do it, and you're like, wow, that was a lot, I want to check it, you go to Desmos, because you know how, right? So use Desmos as a tool to check your work anytime you want, okay? Yeah.
But what numbers like do we have to put an X? Because like in the homework also we didn't have anything, so that's why.
Yeah, so that's why, okay, so you asked what Desmos was before.
We choose.
I will show you. Ready? What is Desmos? Okay,
Website?
it's a website
On the computer?
on our computer.
But like the homework,
On
like 4 and 5, like we had nothing.
Yeah, and you don't need to plug in X's for these to get your Y because of what we're learning, and I want you to learn something now. So this is Desmos.com, so you type in Desmos.com, and then you click on Graphing Calculator, and then you type in your function, you type in Y equals, and then here's a little shortcut, anybody want it? Ready? You know how you have to go down to this keyword to find your square root?
Yeah.
If you type SQRT, it makes a square root for you.
I think that one's faster.
What?
That one's faster.
So this is our parent function, right? Let's just do this since we only have 5 minutes left. And then if I go y equals negative square root x, well, what happens?
It does the upside down.
Oh.
Yeah. If I do y equals square root
Wouldn't that be
negative x, what happens?
It goes the other way.
It goes the other way, right? Yeah.
If you do, can you go erase the green one? Like, wouldn't that be a parabola, but, you know,
Sideways?
yeah.
Yeah. Very good noticing. Because don't they have a relationship squaring something and square rooting something?
Right.
That's exactly why that happens. Good. Yeah.
And isn't the green and blue just cubic in a way?
A sideways cubic function, yeah. Yep. They're all very similar to each other, right? The reason is it's similar to a cubic is because cubic is almost like a parabola, but you're allowed to have negative values. These functions together allow for negative values, right?
Yeah.
All right, hold on, we're not quite done. We gotta finish our notes here.
Can we get home? Tap that one.
You'll get your homework, All right, so this one flips down, right? This one flips left, right? And it's all your key points that do that, So you need to be able to know that. Okay, so you can plug these into Desmos to see what happens, but I want to write down some rules here for you. Ready? How do negatives affect the parent function? They reflect the function over the y or x axis. I'll give you an easier way to say that. Negative on the inside reflects, as you still have 3 minutes, calm down, reflects over y. And if I ask you, hey, negatives on the inside, what's happening here? And you just say it flips left, you showed me you know what's going on, right? A negative on the outside reflects over what? The x. Over the x, and that flips down. And why is this happening? Because we like to ask why. This negates, means makes negative, the input, and this negates, makes negative, the output. Right? So what do I mean by that? Well, this point, 1, 1, became 1, negative 1. The y value became negative. This point, 4, 2, became negative 4, 2. The x value became negative. This negated the input, this negated the output. And that's the lesson. Okay. Homework.